Solution to a 4-mark question that appeared as part of the sample paper given by CBSE in 2019 for class 10 math. Question number 25. This question appeared from the topic triangles. This is a proof question. You're likely to get 1 or 2 proof questions, especially from geometry in the board examination. So be absolutely thorough about all of these proofs. This proof is proving the Pythagoras theorem, this particular question. Prove that in a right angle triangle, square of the hypotenuse is equal to sum of the squares of the other two sides. Let's get started. Let's draw a right triangle ABC. This right triangle is right angled at B. So side opposite to the right angle is going to be the hypotenuse. So AC is the hypotenuse. What we need to prove is the square of the hypotenuse, AC square, equals sum of the squares of the other two sides. One side is AB, the second side is BC. So AC square equals AB square plus BC square. This is what we need to prove. Step 1, I'm going to draw an altitude to the hypotenuse. AC is the hypotenuse, so the altitude will be drawn from the opposite vertex B that's perpendicular to this hypotenuse AC. So BD is perpendicular to AC. We'll use this theorem to solve the question. When you're writing the solution, write the theorem and proceed further. What we'll do in this video is, we'll prove the theorem and then we'll proceed with the solution. So you don't need to prove the theorem in the examination. The theorem basically reads as follows. If a perpendicular is drawn from the vertex of the right angle, a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse. So we're drawing a perpendicular from B to the hypotenuse. Then triangles on both sides of the perpendicular. Which are the triangles on both sides of the perpendicular? BDA and BDC, and the whole triangle, which is ABC. All these triangles will be similar. We'll check out how this came about. We are going to be using the AAA or AA similarity test to establish this similarity. Let's do that here. You don't need to do this in the examination. Let's start with triangle ABC. Angle B is 90 degrees. We'll call angle A to be A. So angle C is going to be 90A. So that's going to be the balance, which is going to be equal to 90 minus A. So we'll write the first triangle ABC. I'm going to mark the values of the angle, which is A, 90 degrees and 90 minus A. So this is what we have. Let's move on to the second triangle. I'm going to look at triangle. Basically, ADB is my second triangle. In ADB, angle A is A. Angle D is 90 degrees because that's a perpendicular drawn. This entire angle in this triangle ADB, this is 90 degrees. This is A. So this part ABD should be the balance, which is equal to 90 minus A. So this is a 90 minus A. A90, 90 minus A, A90, 90 minus A. So we established similarity between these two triangles. Let's move on to the third triangle. The third triangle, I'm going to write it in this order, BDC. Let's write down the angles that we already know. Angle D is equal to 90. Angle C is a 90 minus A. Look at this, entire angle B is equal to 90 degrees. Of that, the portion ABD is 90 minus A. So the balance should be equal to A. So that is angle DBA, that is equal to 90. So that's an A, 90, 90 minus A. So all these three triangles, the three angles are equal. So by AAA rule, we can establish that these three triangles are similar triangles. Let's start by writing the similarity for these two triangles and similarity for these two triangles. Write the proportions subsequently. We're going to start with ABC and ADB. So the sides, corresponding sides are AD by AB, that's this part. And then we are taking AB by AC. So AD by AB equals AB by AC. Cross multiply, what we will get is AD into AC equals AB square. Look at it, we have found out the value of AB square. Using this similarity established between triangles 1 and 2 in our case, we have found out the value of AB square. I'm going to pick similarity between triangle 1 and 3 and run through the same exercise. And I'm doing that, essentially BDC is similar to ABC. So I'm going to pick CD and BC. CD by BC is equal to BC by AC. Cross multiply again, what we'll have is equal to CD into AC equals BC square. What did we have to prove? We needed to prove that AC square is equal to AB square plus BC square. From equation 1, we have found out AB square. From equation 2, we have found BC square. Let's add both these equations. For our reference, I've written AB square here. So equation 1 plus equation 2. On the left hand side, what we'll have, look at this, on the left hand side, it's a CD into AC, it's a AD into AC. So I can take AC common between these two terms. So I have a AC into CD plus AD. That's the left hand side. This is equal to AB square plus BC square. So we got the right hand side pattern place. CD plus AD is nothing but the entire AC. So we can replace the CD plus AD with an AC. So AC times AC equals AB square plus BC square. AC into AC is nothing but AC square. AC square equals AB square plus BC square. That's what we said about proving. So this is a proof for it. Quickly run through this last bit in a printed form. We're adding these two equations. So on the right hand side, we'll have AB square plus BC square. Left hand side is AD into AC, CD into AC. Take AC common between these two terms and then make that AD plus CD to be an AC. So AC square equals AB square plus AC square. Before you leave, do two things. Sign up at online.maxtute.com and get started with your CBSE Class 10 Maths coaching. It takes all of 5 minutes and 3 steps to get started. Second thing I would like you to do is basically subscribe to this channel, youtube.com/maxtute, and spread the word among your friends and classmates.